Today we're looking at a new topic called integration. We're going to start with the basic rules of integration, and we're going to think of it today as a process of undoing differentiation. So integration is to differentiation what subtraction is to addition, and what division is to multiplication. It's the opposite of differentiation. When we looked at the basic rules for differentiation, we multiplied by the power and reduced the power by 1. In integration, we're going to undo those steps. So when we integrate, we have to undo. So the first thing we're going to do is increase the power by 1, and then we're going to divide by the new power. So the main focus for today's lesson is going to be those basic rules. We need to increase the power by 1 and divide by the new power. In the same way that we learned some extra tricks for differentiation as the functions became more complex, we're going to have the same type of things we're going to come across in integration. But for today, we're working on these basic rules. There's no notes for today. We're going to go through some examples together, and I'm going to suggest some questions for you to complete from your textbook. So just to remind ourselves, if I have a function that's 3x squared, if I differentiate, I multiply by the power and reduce the power by 1. If I want to integrate, I'm trying to go back to the original function. So to do this, I'm going to increase the power by 1. At the moment, that's a 1, so I'm going to increase it to squared, and I'm going to divide by that new power. And of course I can then simplify 6 divided by 2, which gives me 3x squared, which is what I first started at. So in blue here, I differentiated the function, and then in purple I have integrated and gone back to the original function. So if I'm given a derivative, which is 3x squared, and I want to get the original function, I'm going to integrate. So I'm going to increase the power by 1, and I'm going to divide by the new power. And I simplify this to get x cubed. And you know from looking at x cubed, if you differentiated that, you'd hit 3x squared, which is what we started with here. So integrating, we're just going backwards. We're going to call this undifferentiating for the moment because there's a few other things we do need to consider with integration. So let's just try a few. If I'm given x squared and I want to undifferentiate it, I'm going to increase the power by 1 and divide by the new power. If I'm given a derivative of 4x cubed, the 4 we don't need to worry about. It's going to be there before and after. The x is a cubed. I'm going to increase that power by 1, and I'm going to divide by the new power, which can be simplified to x to the 4. Okay, I'm given a derivative of 7x to the power of 6. Why don't you have a think and see if you can work out what the undifferentiated function is going to be. The original function, I'm going to keep my 7 there. I'm going to increase my power by 1 and divide by the new power. The 7's simplify, and I get x to the power of 7. Sometimes we've got to consider negative numbers and fractions, so let's have a look at them just now. Okay, if I have a derivative, which is negative 3x to the power of 4, and I want to undifferentiate, I'm going to increase that power by 1 and divide by the new power. And I can leave that like that, and that's absolutely fine. If I have a derivative which is negative 3x to the power of negative 2, and I undifferentiate, I'm going to increase the power by 1, and again be careful, 1 more than negative 2 is negative 1, not negative 3. And I'm dividing by the new power. Now I've got negative 3 over negative 1, so that's going to result in a positive answer of 3. X to the power of negative 1, using my index rules, I'll pop that underneath, and I get 3 over x. Okay, if I have a derivative which is 1/4 of x cubed, and I want to undifferentiate, I'm going to increase that power by 1, and I'm going to divide by this new power. Now a quarter divided by 4 is a 16th. So I can either write 1/16 of x to the power of 4, or I can have x to the power of 4 over 16. And finally, if I have a derivative which is a half x to the negative 2/3, and I want to undifferentiate, I keep my coefficient, I increase my power by 1, so negative 2/3 plus 3/3 is positive 1/3, and I divide by that new power. Now dividing by 1/3 is the same as multiplying by 3, so that's 3 over 2 times x to the power of 1/3. I'm going to use my index rules here to convert that, and so I have 3 times the cube root of x over 2. So let's just check we've got the basics. What are the 2 basic rules to undifferentiate something? And can you undifferentiate each of the following? 3x to the power of 6 and 4x to the power of 1/2. Okay, you are now ready to do exercise 9E. I would recommend doing this one yourself at home, so that when we're in class you can focus more on the trickier questions that come later.